Welcome to Spring LIB.
Okay, we have several molecules. One, two, three, four. Let's another one down here. Five. Okay. A molecule like this. One like this. And one like this. One like this. And one like this. Okay, and the question is, which of these will undergo SN1 the fastest? Well, basically all I have to do is consider what does the carbocation intermediate look like after the leaving group leaves? Supposing that we have, a good leaving group, like the chlorine, it's probably not going to be the one with chlorine, right? Because bromine is so much better of a leaving group. We already know that between these two, bromine would win. So at the very least, we just have no reason to consider the one with chlorine. Okay, it's as simple as that. We can just ignore the one with chlorine, and then we can look at what would the carbocation intermediate look like after the fact, because the energy of the carbocation intermediate will influence what the energy of the transition state that leads to the carbocation intermediate is. So it's sort of a stand-in for the energy barrier, if you will. It's not exactly the same, but it's a stand-in if we want it to be. So we're not totally ignoring kinetics, but we're doing a little shortcut so that we can ignore kinetics. We're making some assumptions. Okay, so now we look at these various carbocation intermediates and say, hey, what's the most stable one? And it turns out, okay, these two may not look at, and your teacher may not have intended it, are the same. That is, if we consider resonance, this has resonance. The resonance hybrid of that carbocation intermediate looks like this, right? Over 3 hydrogens, or over 3 carbons, and this one looks exactly the same, right? Resonance hybrid. Carbocations spread out over those same 3 carbons. But they probably intended for the answer to be this one because the carbocation is both tertiary and allylic. Here we've got a sp2 carbocation, which is just really bad. Here we have secondary, and it doesn't have any resonance. And then this one has resonance, but it's secondary instead of being tertiary. And even though it's quite literally the same exact structure, if you consider the resonance hybrid, which you should, even if your teacher didn't intend it, the answer is 5. The answer is 5 or 1. Because technically 5 and 1 are the same structure once you consider the carbocation intermediate.